Hello, welcome back. This is question 2 in activity 2, and this video is just going to be focused on the graphing portion. So graph the line of the equation you wrote in number 1 and the equation of the line y equals 2x plus 3. Draw a parallelogram using the two lines you graphed and using -4, 1 as one of the vertices. So if you have not watched the previous video in terms of how we got to this equation, please go ahead and do that. I've highlighted the equation from number 1 in green. So we had the y equals 2x plus 9, and then the original equation that we were given, which is y equals 2x plus 3. Okay, so these are both equations of lines, right? And when we want to graph a line, we can just come up with a few different x values. So here I said for x equals 0, 1, and -1. And then we are just plugging in those numbers for wherever we see x. So for this one, for example, 2 times 0 is 0, and then 0 plus 3 is 3. So we know that the coordinate pair, right, would be, I can write that below here as 0, 3. In this next one, if we plug in 1, right, 2 times 1 is 2, and then 2 plus 3 is 5. So our coordinate pair would be 1, 5. So you could pause the video and come up with a few more x values for both of these equations, and then find the y values and plot them on a graph. I am going to speed up this process by using GeoGebra, which is like a graphing calculator software. So what I'm going to do here in my graph is actually type in the equations. So I can type in y equals 2x plus 3. So that is our original equation we were given. And then I'm also going to type in y equals 2x plus 9. Okay, and you'll notice, right, that one of our requirements is to draw a parallelogram, and the second requirement is to use -4, 1 as one of the vertices. And the vertex or vertices are basically the corner points of a parallelogram. So what I'm going to do here is make this a little bit simpler and use my line tool to draw our parallelogram out. So I'm going to draw a line from this point, -4, 1, and I'm going to connect that here. All right, and let me label this in like a bright color here. Okay, so this is part of our parallelogram. Next, I will go up here. And it's okay if you choose a different way to draw your parallelogram, right? I am just choosing one that will be kind of simpler to look at in terms of the coordinates, but if you want to connect different lines to make a parallelogram, go for it. Okay. And then we will end with this last line over here. Okay. So as you can see, we have a parallelogram drawn out here. I am going to label the points as well, because this will be useful for us when we are starting to put our thoughts together for question 3. So I know it just disappeared, but as I'm typing this in, we will see it all together. So I'm going to start with point A at -4, 1. All right, point B, we will say it was at -3, 3. Point C would be at -3, 3. And then D would be at -4, -5. So if you take a look at our parallelogram over here, we've got point A, B, C, and D. And we have now drawn this out, right, through connecting the two parallel lines from before. And we can also check that one of the vertices right here is -4, 1. So this fulfills our requirements. So I will be using the coordinates of this parallelogram to answer the questions in number 3. So if you want to kind of sketch this parallelogram out on a separate sheet of paper, feel free to do that, as that will help us when we're answering question 3.